Three-dimensional learning is an exciting and developing initiative for science education. The shift towards this learning model in the science classroom requires an accompanying shift of teacher and student mindsets. Teachers and students change their focus from transmission of information to application of knowledge through interconnected experiences and applications connected to the world. Disciplinary core ideas, cross-cutting concepts, and science and engineering practices provide a learning model requiring students to be knowledgeable about science, scientific practice, and the ability to apply it in the real world around them. Real-world problems, issues, and challenges can be utilized to help students apply three-dimensional learning to address these situations. Explaining phenomena and designing solutions to problems allows students to build general science ideas in the context of their application to understanding phenomena in the real world, leading to deeper and more transferable knowledge. A well-developed authentic performance task is a strong instructional tool to address the complexities of three-dimensional learning. Using the GRASPS model, or goal, role, audience, situation, product, and standards, allows students to work towards creating solutions to real-world problems, which address disciplinary core ideas and cross-cutting concepts. As students complete research and develop potential solutions, they engage in the work of professionals through the use of science and engineering practices. To successfully create and justify solutions, students will need to apply the disciplinary core ideas and cross-cutting concepts in order to justify their solutions through the creation of identified products. Many of these products may be utilized to inform, convince, or persuade the audience. Let's take a look at how one defined STEM performance task addresses three-dimensional science learning. In this 8th grade task, Aquarium Designer, students are introduced to the topic by watching a career video on how Infinity Aquarium Designs design and install aquariums. Through the use of guiding questions, students begin to apply scientific practices. As students learn about aquarium designers, they learn that regardless of the shape and volume of the aquarium, they need to provide a stable ecosystem for the organisms. Through the GRASP model, students are provided with a challenge of designing an innovative aquatic habitat. They take on the role of an aquarium designer applying for a job. They must persuade the interior design firm that they are the best person for the job. As students begin potential design solutions to meet this challenge, they will create a variety of products that include a design proposal and a photo story. In order to do this, students will apply disciplinary core ideas related to ecosystems and engineering, as well as the cross-cutting concepts of stability and change. The product rubrics provided align with these disciplinary core ideas. The students will need to use a number of the science and engineering practices as they work through the task and product development. Students will need to conduct research related to the task as well as applying their knowledge of the three dimensions. Practices addressed through this process include asking questions for science, defining problems for engineering, planning and carrying out investigations, constructing explanations for science, designing solutions for engineering, engaging in argument from evidence, and obtaining, evaluating, and communicating information. Thank you for taking the time to see how a defined STEM performance task can meet the demands of the new three-dimensional science initiative.